Right now, a signal from the future is hitting your eye, not metaphorically, not as poetry, mathematically, and Feynman spent years proving it could be real. Sounds mental, doesn't it? But in 1941, two of the greatest physicists who ever lived sat down at a chalkboard in Princeton and wrote equations that say the future is leaking into the present, constantly, quietly, across every photon, every atom, every interaction. And in 85 years, nobody has managed to disprove them. I'm going to walk you through Feynman's most dangerous idea, the Wheeler-Feynman absorber theory, the way Feynman himself would have taught it. Take it apart piece by piece, build it back up from scratch, and just as importantly, admit honestly where the cracks still show, because that's how Feynman did physics. Because if it's right, the arrow of time you feel every morning is a comfortable illusion. The universe isn't pushing forward like a freight train, it's negotiating, past and future, shaking hands across spacetime. And the consequences for quantum physics today, for how we explain reality itself, are absolutely massive. Start with Maxwell's equations. Written in 1865, they describe every electromagnetic wave that has ever existed, from radio signals to gamma rays to the light leaving this screen. But here's the thing your physics teacher probably skipped. Those equations have two equally valid solutions. Not one, two, and one runs backwards in time. The first is the retarded wave. It leaves a source, propagates outward at the speed of light, and reaches you later. The way photons from the sun take 8 minutes and 20 seconds to warm your skin. Cause first, effect second. Normal, comfortable. Every physicist on Earth signs off on it without hesitation. The second is the advanced wave. Same maths, same legitimacy, same status inside Maxwell's equations as the wave you just heard about. Except this one travels backwards in time. The effect arrives before the cause emits it. For nearly a century, physicists pretended it didn't count, called it unphysical, and quietly binned it. Why bin it? Causality. If signals can travel into the past, you could in principle warn your grandfather to dodge the tram and erase yourself from existence. The grandfather paradox in full glory. Most physicists decided the maths was just being mathematical, that reality only flows one direction, and moved on. Then in 1941, a brash 23-year-old PhD student named Richard Feynman, working under John Wheeler at Princeton, asked a properly heretical question. What if we don't bin the advanced wave? What if both solutions are physically real? What if every emission is matched by an arrival from the future? Stay with me, because what comes next genuinely upends everything you assumed about cause and effect. The Wheeler-Feynman absorber theory says every emission is simultaneously a reception. Every photon you've ever observed required a contribution from the future. The atom in your eye is doing half the work, from tomorrow. Picture an electron jiggling inside a lamp filament. It vibrates. It emits a retarded wave forward in time, exactly as you'd expect. Fine. But according to Feynman and Wheeler, it simultaneously emits an advanced wave backwards in time, sweeping into the past, hunting for an absorber to grab onto. The absorber, let's say the cone cells in your retina, responds by sending its own advanced wave back through time to the lamp. The retarded wave going forward and the advanced wave going backward interfere with each other. And only when this handshake completes cleanly across spacetime do you actually see the light. Read that again because it's worth pausing on. To see a star tonight, the star 1,000 years in the past and your eye in its distant future have to come to agreement before the photon even leaves the star's surface. That is not metaphor. That is exactly what the equations say. You might be wondering, doesn't this completely shred causality? Surprisingly, no. The advanced and retarded waves interfere destructively outside the handshake region, canceling each other almost perfectly. You can't actually send a message backwards in time. You can only complete a transaction that was already implicitly agreed on by both ends. Feynman's PhD thesis at Princeton, completed in 1942, was built on exactly this idea. He took the absorber theory and used it as the launchpad to invent the path integral formulation of quantum mechanics, taught now in every serious physics department on the planet. His Nobel Prize came 2 decades later. Same root idea. Now, and this is the part most physics channels skip over completely, the same logic doesn't stop at electromagnetism. In 1986, physicist John Cramer at the University of Washington published the transactional interpretation of quantum mechanics, applying Feynman and Wheeler's handshake principle to every single quantum event in the universe. Every electron, every photon, every measurement, Cramer argues, is a real-time negotiation between an offer wave sent from the present and a confirmation wave sent back from the future. The wave function never actually collapses in the spooky way Copenhagen tells you. It handshakes, and retrocausality quietly becomes the engine driving reality. And then there's the experiment that, by every classical instinct you have, should not work, but absolutely does. The delayed choice quantum eraser, theoretically dreamt up by John Wheeler in 1978, performed for real by Kim and his team in 1999, and replicated many times since. The result is genuinely uncomfortable. A photon hits a beam splitter and goes on its way. Whether it behaved as a wave or a particle gets decided after it's already passed through the apparatus, by a measurement made on its entangled partner moments later. The photon, in effect, knows what you're about to do. This is where time travel physics stops being purely science fiction and becomes a serious, peer-reviewed research program published in major journals. But here's the part that will properly surprise you. Not everyone in physics buys any of this, and some of the loudest critics are people who openly idolize Feynman. Let's be properly straight about this. The Wheeler-Feynman absorber theory was eventually abandoned by Feynman himself by the late 1940s. Why? Because quantum electrodynamics, the framework that actually won him the Nobel Prize, did exactly the same job without needing advanced waves at all. It was simpler. It was more economical. Mainstream modern physics largely treats the arrow of time as an emergent property of thermodynamics, not as the result of any handshake across time. Cosmologist Sean Carroll, for example, has argued forcefully that the steady increase of entropy is enough to explain everything. You simply do not need signals from the future. The transactional interpretation is firmly a minority view inside the physics community. It explains the weirdness of quantum mechanics elegantly. Yes, but to date it hasn't produced a single experimental prediction that beats standard quantum mechanics. And in physics, if you can't make a unique testable prediction, the jury stays out indefinitely. That's the honest counterargument, and it's a strong one. An equation having two valid solutions doesn't automatically mean both of them are physically realized in nature. Tachyons are mathematically allowed. Magnetic monopoles are predicted. Neither has ever been observed. And so far, no laboratory experiment has forced the advanced wave issue either way. But, and this is the part Feynman himself never quite let go of, the advanced wave never truly goes away. It hides quietly inside the mathematics. Every time a working physicist computes a scattering amplitude using a Feynman propagator, retrocausality is sitting silently inside the equations, doing its job. Feynman's late lectures hinted at exactly this repeatedly. He said past and future are mathematically symmetric at the level of fundamental laws. Our gut intuition that time only flows one way might be a side effect of how brains process entropy and memory, not a deep law of nature at all. Recent work by physicists like Ken Wharton, philosopher Hugh Price, and Emily Adlam has revived retrocausality as a genuinely serious answer to the puzzle posed by Bell's theorem. They argue with real force that it's actually less radical than the alternatives currently on offer: many worlds, hidden non-locality, consciousness causing collapse. So, is the future genuinely sending signals into the past right now as we sit here? Mathematically, the door is wide open, has been since 1865. Experimentally, completely undecided. Philosophically, retrocausality might honestly be the cleanest fix we have for some of the deepest paradoxes inside quantum physics today. Feynman's real lesson, the one he hammered into his students at Caltech for decades, is straightforward. Don't pretend to understand something you don't. Take the equations seriously, especially when they offend your intuition. And admit, openly and without ego, when the universe turns out to be stranger than your model of it. The Richard Feynman theory of advanced and retarded waves might ultimately be wrong. That's an honest possibility. But the quantum mechanics paradox it tries to solve is real and isn't going anywhere. And every time you tilt your head back and look at a star, something deeply weird is happening. Tell me in the comments, do you reckon the future is whispering back to the past, or was Feynman right to walk away from it? Hit subscribe if you want more physics taken apart properly. And send this video to one mate who still thinks time only flows one way.